Are we supposed to start now? All right. So somebody's going to tell me when the right time is to take a break. So what would you do the math right now and say, what is the right time to take a break? It's currently 3:40. About how much can you stand before you're like, I need a break? About 1 hour, about an hour and a half, and I don't know if there's a schedule for coffee or anything like that. You guys can tell me if there is.
Yeah, in 15 minutes there is a schedule for coffee.
4:30?
No, in 15 minutes.
Oh, so, well, we won't be ready for the 15-minute one. Is there another one later? 50. Oh, not 15, 50. Okay. Well, let's try to run about those many minutes and see where we get. All right, and we'll take that break.
Challenge ourselves at 3 hours.
Exactly. Now, last time I did one of these, I did run 3 hours nonstop, just so you know. All right, so it can get that crazy. And so if you actually go online and watch the intro session that I did for Devoxx Belgium, so I did the 9 Steps to Awesome, which is the introductory session that kind of is the prequel to this session. This is more advanced. That session was 3 hours nonstop. In this case, I think we can afford to take some breaks, but we'll find out. It might be that we have way too much to talk about, and we can easily go for 3 hours. But our focus here is very much on folks who are interested in trying to maximize the most from Kubernetes and trying to understand exactly what they're going to do in this cloud-native world, right? So we're going to basically spend some time going through all the things that are related to Kubernetes. And so in this session, we're going to cover, kind of basic Kubernetes stuff really fast because we're kind of moving on to more advanced content here. I've got a messaging application I want to show you, basically where we sprinkle transactions around the hybrid cloud, meaning I have Azure, Amazon, and Google. We'll start with that and see how that works out. Show you an application that basically is an app now deployed across every cloud, because that is kind of the key point of learning Kubernetes, as your skills are fully portable across every cloud. It doesn't matter if it's an Amazon cloud or Google cloud or Microsoft cloud or an IBM cloud or whatever cloud vendor you might pick next, Alibaba, et cetera. It's Kubernetes, 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 Kubernetes. And we'll show you that. And we have a very special technique that's using AMQP and a technology called the Cupid Dispatch Router from the Apache project, and we'll show you that one. And then I'm going to show you some Kafka stuff, right, because there's something real net new I just got working over the last couple days, show you some Kafka stuff, all within the context of running in Kubernetes and OpenShift. Then we're going to definitely show you some Istio and how all the magic things you can do with Istio over and above raw Kubernetes, but Kubernetes plus Istio, service mesh technology, so the dark launch, the canary launch, the how to change route rules on the fly. You guys can also try along with me because it's on a publicly hosted URL. We'll give that a try. And then I also have Knative in here, so we can show you how Knative auto-scale from 0, up from 0, and down to 0 works, and things of that nature. So we have a lot of really cool things to show you over the 3-hour window that we have together. Now, the assumption for this particular session, this deep dive session, is it's going to be 3 hours nonstop. There's no hands-on per se. I do hands-on versions of these too, but we couldn't do that in this 3-hour window to cover all the same things. Normally, it's a 6-hour block to do the hands-on version of this. So today, we're going to mostly do just the lecture and demo everything, let you guys try some of the demos, but we're not going to have you build it on your laptop or set it up on your cluster or anything like that. Okay, so let's try to get going here. Does that sound like it'll be fun? No? You can say, oh, I'm terrified. You can say, I'm terrified now. So we are going to be doing hardcore Kubernetes in this session, all right? So hopefully you've had the intro class that was earlier this morning at 9 o'clock this morning, Docker and Kubernetes intro on Minikube, or maybe you've actually sat through some of the other intro classes throughout this conference, or how many people here have actually put hands-on Docker at this point in their life? Hands-on Docker, D-O-C-K-E-R. All right, so you can do a Docker build, you can do a Docker run, right? Okay, that's 50% of the battle right there. You can Docker build and Docker run. All right, how many people have been hands-on with Kubernetes with kube control, kubectl? Okay, half of you. That's great. For the other half, we might be moving a little bit fast, so just forgive me if we're moving too fast for you. But at the same time, for the half that's already tried this thing, I'm trying to show you more beyond just the basics of Kubernetes, because we want to show you the kind of full capabilities of Kubernetes at this point. So I think even if you've had a lot of time on Kubernetes, there's some stuff here you're going to actually see and appreciate. There's a book that I wrote, so this bit.ly Istio book will get you access to a free copy of it. So you got to do a subscription with the Red Hat team, but our forum with the Red Hat team, but that'll get you access to the book. Also, you notice down here at the bottom of the screen, it says @Burr Sutter. That's my Twitter handle. If you have questions, you can tweet them at me when I'm not here. Also, there's the slide deck, bit.ly 12 ways cloud, so you get access to the live deck. So in other words, if you join now, I'll see that you join. It looks like there's 2 people already joined this deck, as an example. So it's a live Google slide deck, and as I make changes, you'll get those changes because I'm constantly changing things. And this is actually the first time I've put all this content into one 3R bucket, so I don't really know about the timing. It might be I have too much in here. It might be I have too little. It's probably too much. I rarely have too little, but we're going to go through it and hopefully have some fun. But you're going to basically get a chance to see Istio if you've not seen it before. Has anyone actually put hands on Istio at this point? Okay, some of you, fantastic. So for those of you who have been hands-on Istio, you might be thinking, oh, this is stuff I know already. But for most people, it's stuff that's kind of magic. It's kind of black magic when it comes down to people who've never seen Istio in action before. And then Knative, of course, is even more black magic, right? It's like, how does it do that? And we're going to show you those things. All right, so this is the prequel. The intro class there's a recording here. You can go check that out. It's 3 hours online, nonstop. But the nice thing about doing it with YouTube is you can hit the pause button. Or better yet, I talk so fast, you can slow me down. That's what everyone in Germany tells me, because in Germany, they tell me I talk too fast. I don't know why. But actually in this part of the world, normally I don't have any problems, so you guys hopefully can listen fast. And I'll try not to talk too fast. But a quick recap on the Kubernetes basics, just so people get their head around it. You have this concept of the pod, P-O-D, right? The pod is called a pod simply because of this one reason. Well, I like to say it's this one reason. Hopefully you've heard this before. But if you've seen this logo before, okay, you notice it's a little whale. It's a whale. A family of whales, a group of whales, is a pod. And a pod can always be more than one container. So as long as you can get your head around the fact that we're not limited to one container per pod, by default, everything you do in Kubernetes by default is one container per pod, okay? And as long as your mental model is okay with that pod is my computer, my JVM, my V8, my CPython, whatever your runtime is, runs in that pod, and the pod is the computer, okay, you got your mind in the right place, but just keep in mind the pod can have 2 of those things if it wants to, or 3 of those things if it wants to. And that's where the magic of Istio and Kubernetes and Knative start to come into play. So just keep that in mind, right? So this word, the pod, is incredibly important. So it's paramount that you get your head around it. Notice right here, and I'll try to zoom in because I see our screen's very small, but it can have more than one container, as a shared IP address, shared storage that is ephemeral, by the way. In other words, the disk inside it is disk that does not stick around, and you should never count on it unless you're just having fun for development purposes, which is often my case. But you need to, of course, use a persistent volume, and a persistent volume claim is what it's called, if you really want disk to stick around, like for your database, for your Kafka broker, for whatever you need real estate for, right? So that's a PVC. You don't have to worry about that here right now, because we're going to just show you the basics of running things. There's also shared resources. The easiest way to think of this is one computer, okay? In other words, if I bring up a thing on 8080, I can't bring up another thing on 8080, right? It's one IP address. We're kind of living on that 8080 world. So just keep that in mind. So shared life cycle, as this whole pod goes down, everything goes down with it. So if there are 2 or 3 containers in there, they all get shut down. And you could have 2 or 3 JVMs in there. Not that I would ever recommend that, but it's technically possible. This thing's crawling down the back of my head. There we go. There we go. Try to mount it up here better. Okay? Now, in the case of this concept here, the replica set or the deployment, and again, I'm just recapping for people who have not seen Kubernetes before, this is the desired state that you want for your application. I want to say to my deployment, I want 2 of you, and I want 2. The U is this specific image from a registry, and it's just the Docker image, a Linux container image that was created by whatever tool necessary. It could have been a Docker build. It could have been a Kaneko build. It could have been a Podman build. It could have been XYZ, or you could have even rolled your own. As long as you properly build the image so that it launches correctly within the context of this container runtime, you're good to go. Okay? And so from that image, you say how many replicas you want, you say what your environment variables might be, you say what your health and readiness probe ought to be, and those are probably the 2 most important things to get right beside the image name. The image name needs to be right. If it's not right, things don't work. And that'll be one of the most common errors you make in the Kubernetes land is you get the image name just slightly wrong, in which case it says, error image pull, crash loop back off, and you'll see all these errors coming out of it because it can't find the image. And then also keep in mind the liveness probe and readiness probe are incredibly important. So we cover that in the intro class, how important those 2 things are, because a lot of things break if you don't have those 2 things quite right. As a matter of fact, your app may not even deploy if you don't have those things quite right. So you want to set that up in your deployment, okay? So that's the health checks right there, the image information, the resource information. You then have this concept of the service. So the reason this magic works at the great scale it does is because the IP address on a pod is another ephemeral thing. In other words, you should ignore the IP address you have. It is not relevant to anybody from your perspective. It's just an IP address. So that actually is a new Kubernetes user mental problem at many times. They're like, oh, I'm used to jumping, starting up my JVM, and I grab my IP address, then I know what it is, and I can connect here and connect there. Yeah, don't do that. You don't have an IP address anymore. Just assume you don't know what it is. And that was really hard for a lot of people, even within the Red Hat team, migrating in a traditional Java world to a Kubernetes platform. That was the first thing that burned them. They're like, what do you mean I can't, this IP address doesn't belong to me? It doesn't. It's an ephemeral IP address that gets assigned to you, and next time you restart your pod, you may have a completely different IP address, just randomly. Now, so keep that in mind. The concepts of the service is where the real IP address is, but that's a different object that sits outside of you. And the service basically is a built-in little load balancer and a sticky IP address, if you will, that is a load balancer across your pods. And I can show you an example of that, but again, this is the intro stuff. We're just doing a quick recap. But just keep that in mind, right? As long as you understand your IP address doesn't matter, the service's IP address matters, you'll be okay, okay? And then you got persistent volumes, as we mentioned earlier. That's what you have for network available storage. That's your PV and PVC. And then you have the concept of labels, all right? And labels are critical to get your head around because labels make all the magic happen in this world. And if you get those labels slightly wrong, then things don't seem quite right anymore. So always do the -- show labels on your commands to see what labels did I get and why are they there. So we could spend a 3-hour session just doing just these object types, okay? Because this is the core of just getting started as a developer with Kubernetes. You got to get access to a Kubernetes, and then you got to really kind of master these components. Once you know these components, you can do a lot of really amazing stuff with just these components all by themselves, right? You can deploy all kinds of crazy applications at great scale with just these components by themselves. The only other thing you would need to add to this is some form of ingress gateway, and that is going to come to you by your vendor, right? If you go do business with Google, they're going to give you a certain type of load balancer. If you do business with Amazon, they're going to give you a certain type of load balancer. If you do business with Red Hat, we're going to give you a certain type of load balancer. That's just a different vendor-specific thing. That's why I don't call it out here. But that's how you actually talk to the outside world, right? So the outside world basically comes through some load balancer to all the service that you need them to the pods that you need them to. Okay, are there any concerns about these core components from anybody here right now? We have a small enough group we can allow for questions in real time. Is there any concerns about these things, or anybody not quite got their head around these things? Okay, good, because we're gonna, and if you're just too shy, that's okay too, right? You can kind of say, hey, I don't know, I don't really understand that thing. But you're also going to see these things as we go deeper, okay? Now, here's one thing I want you guys to get your head around right out of the gate. For those people who've already touched Kubernetes, this might be 3 tips that are incredibly valuable and worth your 3-hour price of admission today. And that is the bottom one here. It's called kubectl get CRDs. Here's the thing you should mentally think about going forward. There are no 2 Kubernetes clusters alike, period, ever, again. The beautiful thing of Kubernetes, it's kind of this nice standard infrastructure that we can throw our apps at and make them run, yet they've added this thing called a CRD, a custom resource definition, which means now anybody can expand the API surface of Kubernetes in all kinds of clever ways. And that world has exploded. So let me give you a feel for this. Let's kind of run a little demo if we can to see what will work here. I'm going to go over to a Minikube. Let's see, my Minikube is running. Let's see here. Okay. Let's go, so kubectl, API resources. I'll just show you this command. Wait, kubectl, API resources. Misspelled it. There we go. All right, so you notice these are the standard objects, the standard API elements. This is the stuff that's already in etcd, already part of the database schema. In other words, that concept of the deployment, the job, we talked about deployment, that's right here, right? We talked about, you'll see pod in here, you'll see replica set, you'll see service somewhere in here, right? Basically, the standard stuff is kind of here. And then you do this, kubectl get CRDs. And there's nothing in my minikube right here under kubectl get CRDs, because I have a bare bones minikube, nothing special, nothing done to it. Now I want to make that point, and this is, again, if you've done work with Kubernetes before, this is the part that gets crazy. I think am I connected to the right one here? kubectl version. Oh, let me see if I'm connected to the right guy here. I am not. I keep different ones in different windows, right? So kubectl get CRDs. Oh, and it even took a while to draw down that long list of things. All right, so this right here, what I just showed you probably should blow your mind. Because this means my Kubernetes cluster has been extended, I don't even know how many ways, with these custom resource definitions. And what this means is I now have this thing called a stack driver if I choose to use it. It's a whole new piece of schema, a whole new API that I can just use, a new object type that I can just throw at. I can basically say, oh, here's my stack driver, instance stack driver, instance stack. I've not even tried stack driver. I have no idea how it works, but I might. Now, the ones we'll see today are this one called virtual services. We're going to spend some time on that one with Istio. And a virtual service is very, very special. It's not your normal Kubernetes service. It's the Istio virtual service that allows for really fine-grained routing logic in between your services. It means you can do some really specialized activity over what users go where, what transactions go where. That's how you get your dark launch. That's how you get your canary launch and things like that. So we'll show you the virtual service. But that's a new object type now that's part of this cluster. Once you install Istio, it installs Istio custom resource definitions, the CRDs, and one of them is virtual service. We're going to see some other in here. What else do we have? Routes, are going to be interesting. Prometheus. You can kind of see there's a lot of interesting stuff in here. And actually, let's kind of make this list a little bit smaller. Kafka. This cluster has a Kafka resource. In other words, I'm going to be able to build Kafka objects now. Just like I do a deployment, a pod, a replica set, a service, like any other Kubernetes object, I now have Kafka objects as part of my overall API surface. So this concept is incredibly powerful. You can build your own CRDs. You can create the beer pizza CRD if that's what you want. And then you can build your own controllers that respond to those objects as those objects are updated in the API. So the easiest way to think of Kubernetes, right, it's kind of like this API, REST API, with CRUD operations, create, read, update, and delete, against a database called etcd. And etcd is the database. And you're simply saying, I want to create a deployment. No, delete the deployment. No, let's replace the deployment. Or I want to create the Kafka. I want to replace the Kafka. I want to delete the Kafka. I want to get the Kafkas. And I don't know if I have any Kafkas here right now. kubectl get Kafkas. And we don't have any yet, right? No resources found. So we're gonna go make some in this presentation. So I want you guys to go, this is the advanced course, right? This is the, oh Lord, I already know some Kubernetes. So CRDs are what I mean by advanced, because you can see that my Kubernetes looks nothing like the Kubernetes you've ever had before, probably. All right, I also have like my Knative stuff in here. Well, not that. Let's get CRDs, prep, Knative. And so one of the things you want to do as a person touching a new Kubernetes cluster is run this command. What does that cluster have as far as its capabilities? Get CRDs. That's there's other ways to do this without CRDs, and hopefully no one's done that to you, but you might have that specific issue. All right, you want to check that out. So if I want to check out Istio, I can do this also, and I can now see what's going on in the world of Istio. Okay, so we're going to have some fun with that. Let's kind of hop back over here. Let's explain this concept real quick. Okay, this is by default the way you should think of a Kubernetes cluster. The cluster is simply a bunch of computers, bare metal hardware, or virtual machines. In my case, I'm running virtual machines up at Amazon right now, and Azure and Google, and one on this laptop. So I have a Kubernetes cluster here, and I've got 4 running in 3 public clouds at this moment, just for the sake of having stuff to show you guys today. But those nodes are either a bare metal machine, right, or a virtual machine. They have this concept of the kubelet on it, and that kubelet's job is basically to say, hey, Docker run, Docker run, Docker run, and it does a bunch of other smart things. I'm just kind of oversimplifying it. But its job is to make sure that the workload runs on that computer, right? I want to run this Tomcat on this computer. The kubelet says, all right, I'm making sure the Tomcat's running. If the Tomcat dies, I will let you know that it died. Or if there's something else going on, I'll let you know. But this concept of the kubelet talking back to the master is a key thing to understand. There's typically 3 masters in every production server, production cluster, because etcd needs 3 for a quorum, right? So you always want 3 masters, and that's 3 different VMs all by themselves, or 3 bare metal machines all by themselves. There's plenty of people trying to get by with 2 machines. Well, you know, that's not really how it's supposed to work. You could have an outage. You could lose. You don't really have a high availability in that scenario. But the concept of you basically saying, I want to talk to this API. I'm going to create this new object like Kafka, and that basically gets added to the etcd into the database, and then the schedulers and controllers kick in and say, you want a Kafka? Are we allowed to do Kafkas here? Yes, we're allowed to do Kafkas, thanks to the CRD, thanks to the operator. We'll talk about operators in a second. And it then says, hey, nodes, who's got availability? I need to land a Kafka on you. That's probably so big. Hopefully people specified how big that was going to be. Do you have room for that? And it's going to land it on you. So if you notice, I actually put some bigger boxes on here to basically say, well, it might be that not all containers are created equal. They're not all the same size. I might have a little tiny Quarkus-based microservice that's 50 megs of RAM, 20 megs of RAM, and a Kafka broker sitting right beside it. Okay, and I've done this, and I've also kind of wasted some nodes before. You know what I mean? You can have some fun with this sort of thing. I'm actually pretty sure that in one load test recently that a team and I were working on, that we burned out a server in the Amazon data center. Because at one point, our node just disappeared. So we filed a ticket. They're like, yeah, hardware failure. So there is a real computer back there someplace that has to be working at some point, but you're going to basically install it as a node in Kubernetes, and then, of course, you then run your apps on it. Okay? So this basic mental model is also critical to understand. Typically, it's 3, and 3 is kind of the bare minimum. Right? 3 masters, 3 workers is kind of where most people go. In this case, I drew 6. Right now, I think I'm running 4 in my big cluster. And others, I'm only running 1 each. So it is possible to run a master and a worker in one node. That's what Minikube is doing. Right? Minikube is master and worker all together. And you can even do that at other places, too. It's just that's not recommended for any production workload. Okay? I just want to give you this right here. This is kind of a kickoff thing I do in a lot of my presentations. And that is, these are the key elements to be thinking about on your journey when it goes to cloud native architecture, cloud native development. These are things you have to kind of master in order to really be successful in this new world. So I have whole presentations on DevOps alone, and it's interesting to me how many people want to jump to microservices and jump to cloud native, and they don't want to do DevOps. All right? As a matter of fact, I imagine there's someone in this organization or this room right now who works at a company who has a DevOps team. You notice I said a DevOps team, and often there's not even a single developer on that DevOps team. It's just an ops team. That's the most common organizational structure I've seen. In other words, there's one new silo called DevOps. That was the wrong thing. We're all DevOps, okay? Not one team, everybody's DevOps. Otherwise, you're not really doing DevOps. And so just keep that in mind, that that's going to have a fundamental change on the way you build software more than anything I show you today. So the embracing of that new culture of how to build software fast and fast cycle time. This self-service on-demand elastic infrastructure, this is what you wanted when you chose Kubernetes. You were no longer wanting to live in a world where you basically said, hey, I need a new virtual machine. Let me file a ticket to get Vice President A and Vice President B to sign off on a new virtual machine, and then boom, I get one 3 weeks later. You didn't want to live in that world any longer, okay? Now, some of you are like, I still live in that world. I appreciate that. I talked to one customer recently, it was 6 weeks, not 3. Now, you're probably thinking, we're pretty sharp at my company, it's 1 week. I respect that, but in this new world, with Kubernetes, I can do it in about 2 seconds, and I wait for nobody. I use an API, and I have a quota that ensures I don't go way beyond my boundaries, but otherwise, I can light up a new app server or new technology. I want to try that new Apache Spark thingy-majiggy, or I want to try whatever, Kafka, I can do it right now, okay? Also, think about your automation, all right? So what are you doing? Are you basically feeding CDs into CD trays any longer? No. So I want people thinking about automation. You want to fully automate this. I'm going to show you everything the manual way because you're here to learn, but no one actually runs all these scripts you're going to see running today, right? They actually have a full automation, some form of playbook, runbook, some form of, Ansible scripted playbook, if you will, or Chef or Puppet or something, Bash shell script even, that'll automate all that. You're going to have some form of CI/CD deployment pipeline. You're going to then think about your deployment techniques, your blue-green deployment versus your canary deployment versus your dark launch versus eventually, once you're super sophisticated, an A/B test, but that's really very sophisticated, like only the most unicorn of unicorns are really doing those sorts of things. And then you can be all about microservices. And this was originally part of my Teaching Elephants to Dance presentation. I've also done a version of it that was superpowers. So this is my Wonder Woman version. But I also did another version, a Bruce Lee version. Okay? And I've got more versions. But this is kind of how much I believe in this core philosophy of this journey that we're all on. And I do see these things as prerequisites to moving to the microservices world, yet everybody's like, I'm going to stick with my old way of doing things and jump directly into the deep end of the pool and drown. And what ends up happening, and I could talk about this at great length, is you're not really doing microservices. You're simply using Spring Boot, monolithic Spring Boot, in a monolithic app, and you called yourself microservices. Perfectly fair if that's what it took to get over the boss's head, because they don't understand this stuff. But you at least can say, we're doing microservices. We have one. Notice there's a plural at the end of that word. There can never be one. All right? So, any case, the 12 ways that we're going to spend some time on today, and we're going to really try to focus on some of the things here that are super fun, is we're not going to spend a lot of time on DevOps and Agile. We'll talk about that briefly. I want to talk about skill portability, but more importantly, I'll show you that. All right? I want to think about this on-demand, never wait, always automate. We'll see some of that. I don't have time to do the pipeline stuff today, but it's just something I haven't had time to work on. But we just know that your pipeline could easily be automated, executed within the context of a Kubernetes cluster. Most Red Hat customers that run their Kubernetes cluster with OpenShift, right? The Red Hat version of OpenShift. The Red Hat version of Kubernetes. It's our distribution of Kubernetes. They run a lot of the pipeline stuff directly in the cluster itself. That's a very common, and popular feature as an example. But you got to think about your deployment techniques. We'll show you blue, green, canary, dark launch today. You got to think about this concept of application architecture versus application infrastructure. You'll see that when we get into the Istio piece. Okay, it'll be more obvious what I mean there. Of course, we're all about Linux containers. That's really the world we're living in now. In other words, these are all Linux containers. That's the workload of choice that we're running within this Kubernetes cluster. And by the way, one of the things Red Hat has done is we've also made it work with whole VMs as well. In other words, because we're the Linux people, we actually figured out a way to make a pod out of a VM. It doesn't have to be a container. But, I know it's kind of mind-blowing if you think about it, but it's possible. We've done it. We actually demonstrated that 2 years ago in a significant way, and we've since been continuing down that path. And we're building out a product to support real customers on it. A Kubernetes cluster that has VMs and Linux containers living side by side. And it's kind of cool, right? So the way we demo it, we actually have run a whole Windows server. And we actually can RDP into it and show you running Visual Studio. And the joke that I had was run Minesweeper and Solitaire in a pod on a Kubernetes cluster. It's got kind of a different mental model. But really, we're here today to learn about Linux containers. Of course, we have this Kubernetes and OpenShift across the hybrid cloud. You're going to see the service mesh capability. Let's see how many of these features we can get working here. We're going to talk about Knative for serverless. My build, I didn't finish my build demo. I have parts of it working. We'll look at parts of it, and then I want to show you the Kafka stuff, and we'll show you the Kafka stuff kind of up front. So going beyond just HTTP, all right? So the whole point of those 12 things, which we're going to see bits of them all throughout this presentation together, I think this is a great quote from Bruce Lee here, adapt what is useful and reject what is useless. You might decide, you know what, that DevOps stuff is not for me. We like our silos. Okay, I appreciate that. You love your silos. We love our waterfall, and actually it's a water scrum fall because we do these little sprints and mince the waterfall, but I appreciate people love their waterfall. I'm telling you that if you really want to leverage all this fancy stuff, you got to do things differently, okay? So, and add what is especially your own. So let's show you this. I want to start with a demo, if it works for me. This is a very complicated demo, and let's see if I can get it to work. Not that one. Okay, so you want to bring up your phone and go to bit.ly hybrid cloud 3. Move that over there. Google, okay, yeah, this looks good. So you want to go to that URL on your phone. It's going to bring up this user interface. And you're going to be able to put messages in to my application, okay? And I'll show you what this application does in a second. So let me type in one message here. I'm just putting the word one. And notice it says hola, 1, all right? Somebody just added test 1. Someone added 2, all right? You can type in whatever message you want. And notice it's AWS that's responding. Because the way this application is architected is across all the clouds. My goal with this demonstration was to make you understand that the reason you chose a Kubernetes-style architecture and not gone straight up Azure or straight up Google is because now you can build an app that goes across any cloud. So that's what we've done here. It's the same app. I had to redeploy it this morning across the clouds. Boom, 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 boom. And as long as you have a Kubernetes cluster there, you're good to go. So you can see there's people adding messages. And watch the way this is going to play out. Let's go here to here. And let me just show you this real quickly. So I have this Amazon one's one of those all-in-one master and worker nodes all together. Okay? And I have the OpenShift console here. And one of the things, and the OpenShift console, of course, looks the same across all clouds. This is, again, our Kubernetes distribution. It is just regular Kubernetes plus a nice user interface and a couple other little features. Again, our distribution of Kubernetes. But I'm going to turn off the responder, the worker node on the messaging responder there on that application. So now if I type in another message, you notice it's coming from Burr, right? So basically, I now have Burr responding, because if you look back over here, if Amazon is down, Burr is the next one in the chain, okay? If I come over here and turn off Burr, let's go find this one, dun, dun, let's go over here. And this is a different version, so it looks a little bit different, but I'm going to turn off Burr and go back over here, and 3. Notice it's Google now responding. So I'm failing over across these 3 clouds, and technically it's 4, right? There's 4 clouds. I'm failing over. If I go turn off Google, here's my Google, and here's my Azure, by the way. But again, I have OpenShift deployed out there. So let's go here and turn off the one on Google. And so well, I can't, doesn't matter what I type there. But now you can see we're going out to Azure. So as long as Azure stays online, I'm good. My users are getting responses. You guys are getting responses right now. And you can kind of see at the bottom here on this, there's only one worker still alive, and that's Azure at this point. But I can come back now and say, well, let's spin up Google again. Let's spin up the Burr one again, which is this one over here, this fancy one over here. And I can even spin up Amazon again, bring those resources back online. And what's kind of neat about that, if I go back and look at my topology view, I can also look at the message flow here. And so when we have some messages flowing, you'll see it animate stuff, right? There we go. So Amazon is processing the load right now. Let me bring up a load generator on Amazon. So it's going to come online again. So you can see it's the Amazon console, which is very unique. It's the Kubernetes OpenShift console on top of that. It's the Google console, which is very unique. And it's the OpenShift console on top of that. It's the Azure console and OpenShift console. I make this point because I had to go set up these things on those 3 clouds. And these worlds are very unique one from another. The way you deal with Azure is fundamentally different than the way you do with Google, which is fundamentally different than the way you do with Amazon. But once you have your Kubernetes set up there, it's all Kubernetes to you from this point forward. That's the most awesome thing about it. And that's why I like showing this part of the presentation, is to give people a feel for that. And you're going to see right here, it's kind of hard to read, but I'm processing about 2,500 to 2,800 messages per second on Amazon, right? Because by default, our routing, this is the Qubit dispatch router idea again. It's using AMQP, right, a standardized wire protocol for interoperable message brokers. You can actually hang other message brokers off this mesh, which is kind of cool too, like an active MQ. But what we're going to see here is that it's trying to stay local. Don't go across the internet if it doesn't have to. Stay local, stay in that Amazon data center, process them locally. And so it has some understanding of latency. But if I kill Amazon again, let me come over here and kill the worker node in that, right? So let's drop it back down. And if we catch it quickly enough, there, all right, it all failed over to Burr. So again, we should be back on Burr, my message.
And how is the choice? Why it's actually hitting only one worker?
The way this is set up right now, it's basically, it's in that order, right? Literally, it goes from Amazon to Burr to Google to Azure. You can configure it, though, any way you want. I mean, I did it that way to make it more easily to understand. You could also set it up to go multiple directions. One thing is also kind of clever about this. You see it is kind of hitting Google a little bit. But one reason it's probably not putting more load on Google right now is Google's in India. So it's also latency smart. So the Amazon right here is running in Europe. This one's running in Europe. This is running in India. This is running in California. So these two guys right here are running in California. So depending on where your data centers are, it also is smart about the latency and the round-robin load balancing based on that too. But you can see it's trying. If I come drop my Burr again, let's see what happens here. Dun, 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 dun. And you'll see it kind of go around as it responds here. Oh, I got to hit the save button, right. There we go. In this case, now it's kind of said, okay, you know, based on the latency, based on everything, you know, Azure's probably a little faster than Google being in India, but not much.
And where is this? Oh, Azure and Google are running in
Yeah,
India,
so Google's in India, Azure is actually in California.
and where is that?
And where this user interface is actually back at Amazon in California.
There is a third one, small one. Where is that?
Oh, that's the Amazon, but it's not getting any traffic right now.
Ah, okay.
Because I killed Burr, and I killed Amazon, but Amazon is still running this user interface, right? It just doesn't have any processor. It doesn't have any worker responder on it. So this concept, though, hopefully gives you a feel for what you can do once you want to get really kind of crazy in this truly cloud-native, hybrid cloud, run on any cloud kind of model. So it's not that the application is easy to deploy across any cloud. It's the same code base, same exact everything, except for a little configuration that says, oh, your brothers and sisters are over here, here, and here. Like, who are my peers in this mesh that I've created? And that's it. And some certificates, right? So they can make the connection using, you know, they can encrypt their, make the connection, encrypt over the wire so you don't have people sniffing the data across the internet. So there's no VPN here or anything like that. It's just encrypted from the dispatch router perspective. So this technology that makes this magic happen is called the Cupid dispatch router. Okay? But I just wanted to give you a feel for that. And actually, we're going to go through a rename on that and a rebrand. And because it's such a clever thing, we want people to understand that that name is just not very clever, if you know what I mean. I mean, you're not going to remember Cupid dispatch router when you walk out of this room. So we're going to come up with a new name for it. But it is that concept of hybrid cloud interoperable messaging. Okay? And again, you can hang other AMQP guys off this thing because it bridges AMQP from A to B. That's what its primary job is. It just can do it across any cloud. Okay? Now, I want to show you something else, though. Right? Let's get back to the CRD concept. So let's do this. Get pods. So, oh, I'm in that one. All right, so let's do this. Make this a little bit bigger, a little easier to see. I'm going to say kubectl. So this is the first thing you do when you're sitting down with a new Kubernetes cluster. You're going to say create namespace unless your ops team has given you a namespace. So I'm going to create a namespace called Krakow, okay? And then I'm going to switch to it called Krakow. So Kubernetes is a special utility that makes the namespace sticky, so I don't have to type it every other command, all right? So that's a special tool. That's one good tip for those of you who've been using Kubernetes for a while, and you're like, damn, I'm tired of typing namespace every command. Kubernetes, and it's also part of kubectx. Right there, that tool, it's really part of that tool. So you brew install kubectx, you get Kubernetes, and now you have sticky, right? Sticky namespaces. And so I have that namespace now, so I say kubectl, get all, and let's see if I have anything in this namespace. And normally, and the network is slow. Come on, network. There we go. And I notice I do have some stuff in this brand new namespace right out of the gate. And so again, I told you this is kind of the advanced session, right? So because I've installed Knative, and it has certain CRDs that are marked as non-namespaced, they show up in every namespace. So you're actually going to see, once you install certain other things to customize your cluster, they're not namespaced per se, they're in every namespace. So even though this is a brand new namespace I just created, which is normally empty, if I do the same thing on Minikube, it'll just be empty. There'll be nothing there, which is what you expect, right? It's like a new piece of paper. It should be clean. This one has something in it. These are just Knative in-memory channels. You can ignore them or deal with them or whatever, or you can just not install that as part of your cluster, okay? However, I want to show you one other thing, though, in this cluster, and that is, let's go here to projects. And so what do I call this thing? I call this Krakow, right? So when I click on that, make this a little bit bigger. Okay, so you can kind of see there's no pods or anything running in here. But let me show you this. I have installed, remember I talked about the CRD concept and all that? I have installed the Knative eventing operator that gets me the CRDs, custom resource definitions for Knative eventing, which we'll spend more time on later in our session today, and Knative serving, we'll talk more about that. But it also gave me this one called stremz Apache Kafka operator, because I want Kafka to be just like any other thing in Kubernetes. Okay, so you kind of have to bear with me there. So let's try this. Let's do this, watch. kubectl, get pods. Well, it helps if you spell pods correctly. Here's what we're going to do. We're going to deploy a new Kafka on the fly. Does anyone here use Kafka? All right, good, for a number of you. Is it fun and easy to install? You can say no. It is not fun nor easy to install. Yeah, I'm with you there. But look what, and I only got this thing working just a short time ago, right? So I got it working for myself. The team has been working on this for quite some time. But look what I have here. I have this new thing called a kind. You see this kind? A kind Kafka. That matches that CRD. So I can now throw Burr objects if I have a Burr CRD, or a Kafka object if I have a Kafka CRD, and that's what I have. I have a Kafka CRD, so I now can declare a Kafka object, and you can see I call this thing my cluster. Let's give it a different name. Let's call this the Krakow cluster, just to make the point, Krakow cluster. You can see the version of Kafka that works in this case. I want 3 replicas of the brokers, and you can see here's a readiness probe and liveness probe that have been established, a little configuration. I just went ahead and made an ephemeral storage as opposed to persistent storage, but I can make it persistent storage too, just to make it easy. I basically have also set the resource requirements for this. I want to basically give it 2 gigs of RAM, because Kafka needs some memory, Don't try to run Kafka in 200 megs of RAM, then you won't be happy. So give it some memory, give it some real CPU, right? That's half a core, so that's actually a lot in this world. You might want to give it a full core. And actually you can see the limit is, so this is the request, by the way. So the request is, I need to find a node with at least 2 gigs of memory available and half a core available to even drop this workload there, right? And in this case, the Kafka broker. And then, but I will scale out, meaning I will let it grow up to 2 gigs of RAM or 1 whole core. Okay, so that's the actual limit. This is actually a C groups limit. So if you're familiar with the presentation I've done before, which is Java Docker fail, where we show you how Java just blows up inside a container, it's because Java version 8 by default does not see that there's only 1 core and 2 gigs of RAM constrained by C groups. This is a Linux kernel feature. It's not a Kubernetes feature or a Docker feature. It's a Linux kernel feature. And Java basically says, no, that node has 16 cores on it and 64 gigs of RAM. Let me try to use it all. That's what it does by default.
Actually, it was backported to Java 8.
Yes,
Some time ago.
but not all versions of Java 8. It's 250 something. Yeah, so you got to know you got to get the right version of 8, then you're okay again. Yeah, it's kind of funny. I was actually doing a presentation the day they did that, so I did it real quick, and it's like it didn't blow up. I thought, what the heck? And then I looked, and I had to go to Docker Hub, and it's like, yeah, they just patched it like the day before I did that presentation, so I had to go 1 back, and then it was fine. But you can kind of see, here's my zookeeper. I want 3 zookeepers, right? So again, like etcd, all things begin with 3 here. I want 3 zookeepers, 3 brokers. So let's kind of fire that thing over. So I'm going to come over here, and this file was called my cluster, right? That's the one we put Krakow in. kubectl create-f my cluster. All right, I'm going to just basically now throw that document, that YAML file, at my Kubernetes, and look what's happening. So already, again, there's an operator from stremz, the CRD for Kafka, the controllers for Kafka. If you build a new Kafka and add it to the database through the API, the controllers go, you want a Kafka? Let me make you one. That's really the point of what the CRDs, controllers, and operators do now. So you can build your own. There's an operator SDK. There's a controller SDK. There's a, CRD is just another YAML file. It's all very straightforward. But you can kind of see what's happening. Here's my zookeepers coming online. There's the 3 of them. Then you're going to see my 3 Kafka brokers coming online. And this takes a little while. Kafka brokers are a little bit beefier than zookeepers, but it is running 6 whole things now as all these different pods. They're all thinking they're on different computers. Okay? And so it's coming online. Let me do this while we're waiting a little bit longer. kubectl, get pods, O wide, and let's check this out. So you can even see what node they're being added to. So see that node, that node, that node. So the good news here, it's actually respecting some anti-affinity rules, right? In other words, I don't really want them all on the same piece of hardware. Well, if the hardware dies, The whole point of having 3 zookeepers and 3 brokers is if a piece of hardware dies, it doesn't take down the whole broker, everything with it, right? So different hardware, which is awesome. You can see it happening right there. And let's come back over here, get pods. And notice there's this one. This is the last one to come online. This is a special feature of stremz. This guy's responsible for these 6 people now, right? This guy's going to ensure that they're all there, they're all happy. If one gets shut down, let's bring it back up, right? If we have to do a rolling update of these guys, we know how to do that. So the whole point of so the operator goes beyond the CRD and controller and adds a little bit more intelligence to this world. It basically says your view of the world is not, well, let me back up for a second. A deployment will take care of your 1 pod, or 2 or 3 pods, but it's based on your 1 image and essentially your 1 or more pods. If your pod dies, the deployment and the replica set go, ooh, let me bring you back to life. You died. I don't know why you died, but I'll bring you back to life. This is now at a whole nother scale. When you have a complex topology of where 2 different types of pods, right? One's the zookeeper, one's a broker. The operator's job is to manage all of those guys together as a collective whole. So you might have a web app and a database that it connects to, or in this case, a zookeeper and a Kafka broker. So they're online now. My Kafka broker's up. So I'm going to come over here now to let's go to the Kafka producer application. So I've already done this one, so let me just kubectl create. I've already created the image. And actually, let's go look at the code just so you see what I'm talking about here. All right. I don't want to not show you the code anyway. So is this my publisher? Man, it's so big I can't even read it. All right. Very straightforward here. It's basically if I hit the URL /100, it's going to throw 100 messages at the Kafka. If I threw 10, it's going to throw 10 messages at the Kafka, and it's going to throw 1 message at the Kafka. That's very straightforward there. This is a Quarkus app, so it's very straightforward, right? I have the connector that I've defined. I have the topic name. And notice it actually says localhost for my Bootstrap server. That's because in development mode, I'm working off my local Kafka. But when I go production, it needs to be a different URL there. And that's defined in my deployment YAML. So again, this is a standard deployment YAML, nothing weird here. You can see there's the image name. It's going to pull 102 from Docker.io. Okay, so you're going to actually see a lot of different registries at this point. It used to be everybody pulled from Docker, and that's what Docker.io is. But now you're going to see GCR.io, which is the Google registry. You're going to see Quay.io, Quay.io, which is a Red Hat registry under Quay. It was part of the CoreOS team that we acquired, so we have that registry. And you also see the regular Red Hat registry, which is the pristine images that we're guaranteeing, or the CVs have been fixed in and things like that with the right version of Linux, the right version of JVM, right version of V8 for Node, et cetera, Python, all that. You'll see the Red Hat registry. Those are the 4 most common registries that you'll see in this image tag here, right? So Docker.io in this case, just because I'm making everything freely available out to the world at large. Image pull policy always, only because I'm in development mode. You would never use always in a production world, but since I'm constantly hacking, I just like to say always there. Normally you say if not present, and you might say never, because you only want to have images that you know where they came from, and you don't want developers pulling any random thing from Docker Hub, because if you actually go out there and do a scan of Docker Hub, you'll find that those images have hundreds, if not thousands, of critical vulnerabilities and exploits still in them. So, that's because there are anybody who puts them up there. Like mine have issues, the ones I publish, because at any point you publish and create an image, it's got an issue the next day. That's the nature of what we're living in, the world we're living in now. So you got to have a set of build machinery that's constantly reproducing these images in a very clever way. But that's a whole different topic, all right? So here's my cluster. Let me see. Oh, and actually, this is a good point. It's now my cluster. I called that Krakow cluster. What happened there? I messed up already. Now I'm curious. I thought I called it Krakow cluster, didn't I? No, I didn't save it. Okay, well, it's my cluster, but it should have been Krakow cluster. I thought I saved it. But so that's my cluster there. And so therefore, I'm going to connect to it over here, right? My cluster. That's what it is. And so if I deploy this guy, same technique as before. Kubectl is the deployment here. Yeah, kubectl create -f deployment. The producer is going to come online now. and you're going to see it pop in here once it gets through its deployment lifecycle. All right, so kubectl get deployments. You're going to see there's the entity operator. That's, again, the magic operator thing I mentioned earlier that's kind of monitoring the world. There's my producer that is coming online right there. Now it's 1 for 1 running. 1 for 1 means that it's all good to go. These guys over here are 2 for 2. That's because they have a sidecar, a second container living in that pod. This one is just a bare naked deployment I just deployed, so it's all good and happy. Let's see here. Do I have any services? I have the zookeeper and brokers, right? Those are services. But let me see. Let me create my service. kubectl create -f service. This is the standard Kubernetes way. If you don't use another special feature, you create your deployment. Well, you create your image. You create your deployment to deploy the image. And then you create a service if you want to expose it with an IP address. And then I can say get services. Again, we should see the Kafka broker one, or producer one, I should say. And then there's a special feature built into Kubernetes, Red Hat's OpenShift. I'm going to expose that service, which gives me a externalized route. In this case, it's based on HA proxy. So come on now. kubectl get routes. And then, so here it is. So you guys can actually talk to this thing too if you want. Okay? And so let me put it here. And right now I have the 1. Okay? So it sent 1, but there's no one receiving on the other end of that. So let's go over here now. I want to now say, let's look at this deployment here. So this is the consumer. It's going to go through the same process as the others. So it's just saying Burr input. It's receiving the input. If I look at the application properties, the input is tied to topic here. That one, that looks okay. I actually have an older version here, so that's kind of funny, but I think I'm still okay. And you can see there's the Docker IO, consumer 102, always, my cluster again, and let me deploy that. All right, so kubectl create -f deployment. Let's see if it'll come online over there. And while it's trying to do so, I'll put up a log scanner here, consumer. And yeah, Kafka consumer, there we go. And so watch what's happening there. It's got you can see it, there's one message that came in. And if I come over here to this user interface, again, let's kind of make this a little bit smaller. Yeah, we don't need that anymore. But let's do this. Here. Okay. All right. Come on. I got to find an easier way to make this a little bit prettier. There we go. So if I come here now, say 11111, right? There they go. Let me make this a little bit bigger here. And if I want to say, let's send in 100. Okay. So my broker's working. It's pumping messages from this producer, which is a simple REST UI, through the broker into this consumer over here. You can see I've sent 510 messages all of a sudden. Or maybe someone else sent some for me. But the concept is very straightforward, right? You have your deployment, you have your image, your deployment, your service, you deploy your application, your Java logic, your Spring Boot app, your Node.js V8, your Python, whatever it might be. And then now you have these other capabilities that are part of your cluster based on the CRD, like this Kafka concept. Okay? So if I come back over here now, kubectl get CRDs, get Kafka. There's my cluster. And so all the standard rules apply. I can basically say describe Kafka my cluster, just like I would a deployment or a pod. There's the description of it. I can, just delete it, etc. So let's do that. So watch kubectl get Kafkas. There it is. And actually, let's just look at the pods. It's much more interesting that way. And I can say kubectl delete Kafka my cluster. And so I'm deleting the request from my cluster, and it says, oh, that means I can tear down all this infrastructure that you had. You can see it's terminating and going away right now. So that concept, that CRD concept, is incredibly important to get your head around. I can now have extended the cluster in all these amazing ways, and now I can interact with those extensions using the standard kubectl behavior I'm always used to, right? I can create it, I can replace it, I can delete it, I can just get it, which means get means read. Standard create, read, update, and delete, and you can see there it goes. You can see my consumer's now complaining, I can't find my broker anymore. I killed the broker. I could bring a new broker back up and find it, connect to it, but right now, my Quarkus application's not happy. There's no more broker. That's fine. kubectl get deployments, and kubectl delete deployment. I can also wipe the deployment out this way. Consumer, get rid of that one. And producer. And the good news is, if I did have a quota assigned to me for cores and memory, I'm now freeing up that space. I can try a whole new experiment now. So remember that point I made earlier about you want kind of self-service on-demand infrastructure? That's exactly what we just did. Okay, I built a whole broker. I built my consumers and producers. I just wanted to try something. I don't need it anymore. And now I have memory and CPU back. Now, is this the point where we did have the break? Is that true? Okay, I don't remember. But do you guys want the coffee break right now? Because this is a good time to take a break. So do you want to take a 10-minute break? Let's do that. So let's take a 10-minute break. We'll go to 4:46, and then we'll come back. And we got way more good stuff to show you.